Imagine traveling in time, some process that would let you go backward in time to witness the events that change history, or into the future to see if mankind survives, and then to return to the present with the knowledge of what will happen tomorrow. The process is intriguing, even mind-boggling, but the science is more real than imagined. The quest for the technology permitting time control is now underway. Private and government investment in this area of research is on the rise and fueling a race leading to discoveries that will change our world and our very sense of reality in ways difficult to even begin to comprehend. This science is real. The advances underway are truly exciting and the possibilities are endless. Join us now as we explore the possibilities of time travel and begin our exciting journeys into time. Hello, I am Dr. David Anderson, and I thank you for joining us as we prepare to take some exciting first steps as we journey into time. Perhaps the best place to begin is at the beginning, with a definition of time. What is time? What is it that clocks are measuring? They seem to measure some unseen medium that continues on with a constant and never-stopping force. In fact, time is often thought of as a river that flows in one direction and slows for no one, always sweeping everything and everyone along with it. We certainly experience the passing of time. We are born and live our lives feeling as though we are constantly being pushed and pulled by this unseen phenomenon. So then, what is time? Well, one thing I do know is that time is a very curious thing. Ask anyone on the street if they know what time is. They are sure to answer yes. But then, ask them to explain it to you, and they will almost certainly be at a loss for words. Think about it. Something that dominates our language, our everyday thoughts and life, but yet we can't explain it, nor do we understand it. Perhaps in some ways, we don't want to understand time. People do often talk about time in a very negative way. Perhaps because in some ways it is linked to our own mortality. A very popular quote about time from the science fiction movie Star Trek Generations is, "Time is the fire in which we burn." Another is the famous quote from Hector Berlioz, a great 19th century composer who said, "Time is a great teacher, but unfortunately it kills all its pupils." But this still doesn't explain what time is. We seem to have a belief that time exists independent of us. But is it perhaps only something that is measured only by our minds and bodies' perceptions? We all seem to have biological clocks inside of us that work on a set schedule, and our minds perceive the passing of time in many different ways, even for people experiencing the exact same events. Time also seems to vary with culture. For instance, in the language of the Navajo, there is no past, present, and future tense like those of many languages. Events are talked about with regard to their quality of happening rather than their temporal quality. Is it possible, then, that time may not really exist, but is just an illusion of our mind, created by our own biological and cultural evolution? Well, whatever time is, one thing is certain: man has always had a passion for finding better ways to measure. When it first became important for people to measure time, they didn't have or need wristwatches or clocks. All they needed to know was when the winter was coming, or when they could plant or harvest their crops. For this, the ancient peoples of the earth used the regular cycles of nature. For instance, it was known to them that the sun rises and sets in a regular and predictable way. It was also known that the moon, stars, and planets have consistent and predictable motion through the heavens. And they could keep track of the passing of a day with sundials and other similar instruments. With this knowledge, they could predict the coming of different seasons. There were many ancient peoples that devised very accurate calendars to keep track of time. The megalithic stones of Stonehenge in Great Britain are an example of such a calendar. and the Mayans of Central America had a calendar based on the sidereal year that was just as accurate as the calendars of today. These early measurements of time were based on the spinning motion of the Earth and its rotation around the Sun. It is now known today that these motions are not constant but do vary in time. As history progressed, methods of measuring time's passage became more focused on very regular oscillations of such things as springs and pendulums. Today, official time is measured by atomic oscillations of cesium to an accuracy of parts per billion. We have found many ways to measure time, but still, when we ask the simple question, what is time, we cannot answer. This is not a new fascination with the nature of time. As early as the 4th century, St. Augustine said it very well with his famous question and answer, "What then is time? If no one asks me, I know. If I wish to explain it to one that asketh, I know not." This is indeed a very powerful and sharp insight into the psychology of time, and a very, very old and still unanswered question that has been asked for thousands of years. Our struggle to understand and express time dates far back into our history. "15 millennia before the Greeks, Paleolithic man was expressing the passing of time in his cave art. In the 8th century BC, Homer conceptualized time in his great works. Most ancient civilizations believed that time was cyclic, that it had cycles, especially since everything around them in nature showed a kind of resurrection and repeatability, like the rising and falling of the ocean tides and rivers, the return of the seasons, and the cycles of the heavens. All of these supported this belief. But the greatest efforts to study and understand and define exactly what time is began with the great philosophers of ancient Greece. Some of the most commonly accepted and studied views of time in philosophy were presented by these philosophers. Plato in the 5th century BC treated time metaphorically as the moving image of eternity. Later, Aristotle in the 4th century BC described time physically as the number or measure of motion. Plotinus in the 3rd century treated time metaphysically as the productive life of the soul. And then St. Augustine in the 4th century treated time in a very new way, psychologically, as an illusionary product of our mind. St. Augustine's view is still a very popular and provocative subject today. Could it be that St. Augustine is correct? We have been searching for centuries, or millennia even, but finding a true definition of time continues to escape us, even to this day. So this leads us to a very important question. Does time really exist? Is there any evidence that it is really there? Or is it much like the ether that was once thought to fill the universe? We certainly feel ourselves being pushed and pulled along by the river of time. Therefore, time must exist, right? Perhaps. But consider that time is something that we perceive through our senses, which are not perfect. Is it possible that how we think about time is related to how our brain processes information? One can divide any period of time into a past and a future, from millennia to microseconds. The present is nothing more than a fleeting moment through which the future passes to become the past. If this is true, we are left with quite a perplexing problem. The past and the future do not exist, and the present has no duration. So how can time be measured? St. Augustine suggested that maybe time is measured in the mind. It is not an event itself that is measured, but instead the impression that it leaves on the mind. The mind expects the future, which becomes the present, which the mind attends to, and then becomes the past, which the mind remembers. The future and past do not exist, but in the mind there is an expectation of the future and a remembrance of the past. The present then would have no duration, yet still the mind's attention is always there. So it is not the future that is long, but a long expectation of the future. Likewise, it is not the past that was long, but a long remembrance of the past. So, is time an illusion of the human mind? If it is, then maybe it just might be possible to jump out of the river of time, run up or down along the river's banks, and then re-enter into the past or the future. Perhaps just as easily as we move through the three dimensions of space today. We will see later that this type of time travel may be very difficult, but it is certainly possible within the laws of our mathematics and physics. However, many people in this period viewed time as that real, ever-flowing river that was constant and unchangeable. This view, which we know today is inaccurate, was still the key to the birth of the great industrial age of machines all around the world, and at the heart of this view was Sir Isaac Newton. Sir Isaac Newton was, for all intents and purposes, the inventor of modern physical theory. His ideas about motion and force, for the most part, still have great value today. There have only been corrections to his theory since its inception, but nothing has ever replaced it. In his theory, time was always the same for any observer in any reference frame. For several hundred years, from 1687 to 1905, this is the belief that was held as true by people all around the world. However, in the end of the 19th century, a change was developing in the way that time was viewed in physics. The development of the equations of electromagnetics by James Maxwell led others to investigate their consequences. Among those investigators was none other than Albert Einstein. Just as man was harnessing the power of flight, Albert Einstein, then a young patent clerk, introduced his special theory of relativity, and then later his general theory of relativity. His theories suggested the most strange and wonderful things, that time was not a constant, that it was changeable. His theories suggested that objects that were accelerated to higher speeds would shrink and grow heavier. Also that time would pass slower for these fast-moving objects than for those objects that were left behind. The impact of his theory is shown in a story called the Twin Paradox. The Twin Paradox describes how an astronaut that travels to a distant star and then returns to Earth will be younger than the twin brother she left behind. Today we know this is not science fiction. It is today's science fact. Later, Einstein suggested that the acceleration we feel as we move to higher speeds is equivalent and really cannot be distinguished from the accelerations we feel due to gravity. Imagine being in a closed box, like an elevator, with no windows or knowledge of what is outside and around us. Can we really tell whether the acceleration we feel as the elevator moves up is from the force of an elevator, or the thrust of a rocket, or from the force of gravity? So now it is suggested that not only high speed, but also heavy gravity can dilate time. Einstein's views were not immediately accepted. In fact, it would take years before his theories would be understood and embraced by the scientists of the world. But we'll see later how his theories were proven, and then how they transformed our view of science and the world forever. However, in the early 1900s, this was the world of science fiction, not science fact. But science fiction did have an influence on the development of the science fact of time travel. Science fiction has always been the springboard of science. The power of imagination is often lighting the path to real science. And science fiction's influence in leading the way to understanding the nature and science of time and time travel is no exception. As is often said, to do, one must first imagine. Science fiction has been around for a long time, dating back to as early as 2000 BC in the Gilgamesh epic, a Babylon work searching for ultimate knowledge and immortality. In the 4th century BC, Better Worlds in the Republic by Plato had elements of science fiction. Later in 160 AD, in his work True History, Luciano Samosata dealt with a trip to the moon. In the 14th century, there were many imaginary voyages in Greek and Roman literature. Later in 1627, The New Atlantis by Francis Bacon had strong elements of science fiction. And then later in the 17th century, many trips to the moon were made by Francis Goldwyn, Cyrano de Bergerac, and Johann Kepler. And there are many, many more. However, time travel itself didn't emerge in science fiction until only recently, in the late 1800s. And what a good storyline it was. Time travel in science fiction opens the doors to many exciting stories and possibilities. Imagine traveling to the past to see events long gone, or to the future to see the progress of humanity, perhaps to the past to relive a sweet moment in our life, or to the future to see the outcome of a decision we make today. Now, after more than 100 years of science fiction, these possibilities have a basis in solid, scientific fact. Time travel emerged in science fiction at the end of the 19th century. At this time, stories about time travel forward were really not remarkable. In fact, there was little difference between time travel forward and a long sleep, which would have a character falling asleep and waking up far into the future. This type of storyline was just really a simple way of speeding up time. However, some of the most significant time travel works were written at the end of the 19th century. In 1880, Edwin Abbott introduced his work Flatland, about creatures who live their lives safe and undisturbed in a flat two-dimensional world, like on a simple sheet of paper, at least until one day when a three-dimensional creature, a sphere, passes through Flatland. In 1889, Mark Twain introduced his classic work, A Yankee in the Court of King Arthur. And then, in 1895, H.G. Wells introduced his classic work, The Time Machine. One important question when time traveling in science fiction is, which way to go? Do we travel to the future? It's simple and cannot affect the present. The time traveler is the point of view to describe the new world. In this type of story, the reader sees the future world through the eyes of the time traveler. It is interesting to note that most modern science fiction tales are set in the future. But for modern readers, 19th century novels about the future are not really exciting. But then again, there is one true great exception. The Time Machine by H.G. Wells is truly an exception to this rule. Since it was first published, this book has never been out of print, something most books almost a century old cannot claim. Perhaps it was successful because it took the reader hundreds of thousands of years into our future, where we could see the consequences of our biological and social evolution, where we saw an alien and terrifying world. This stands alone not only as a great work of time travel in science fiction, but it also is now recognized as one of the modern classics of the English language. Which way to go? We could travel to the past. This is much more exciting to today's science fiction readers. It is infinitely complex and exciting and is filled with unlimited possibilities and stories. One of the most popular early works about backwards time travel was Mark Twain's A Connecticut Yankee in King Arthur's Court. Although Mark Twain's great story didn't explore any of the paradoxes of backwards time travel, it still remains a classic today. Another way to go in writing a science fiction story about time travel is called Escape to the Past. In this type of story, the time traveler from the future returns or escapes to the present day. Today, this type of story is not very popular, perhaps because it might be hard for us to identify with characters from the future who may be superior to us. But nevertheless, it is an option that was very popular in science fiction of the past. One of the most exciting elements when we consider time travel to the past is all the paradoxes that are created. One of the most popular, though not pleasant paradoxes, is called the grandfather paradox. Suppose I travel to the past and kill my grandfather. Since I killed my grandfather, I was never born, and so I couldn't time travel to the past to kill him. So he's alive, and now I am born, so now I can travel to the past and do this. But if I do, I won't be born again, and well, you can see where this will go. There are hundreds of stories about similar paradoxes that are created in science fiction stories. Time travel to the past can quickly create storylines with an infinite complexity of knots and excitement. But are these truly paradoxes? What I mean is that, for example, most people would say that it's nonsense to suggest that moving objects shrink and grow heavier, or that an astronaut who travels to a distant star and returns will be younger than her twin brother she left behind. But this isn't science fiction. This is today's science fact. So perhaps paradoxes are just simply places where our rational minds bump into their own limitations. Another interesting tool used by science fiction writers is the time police. These are the heroes that show up just in time to prevent someone from altering the past and destroying the future timeline and our existence as we know it. But what happens if the time police don't show up in time? Watch out. We might see the creation of new timelines and see a today or a future that is quite different than what it was before. This type of time travel story in science fiction is called alternate worlds. Alternate worlds, it's an easy idea. Simply take some event in world history and imagine what the consequences might be if we traveled back in time and caused that event never to happen. It sounds so simple, but think of the consequences. An asteroid misses the Earth, and the dinosaurs live and become smarter. Or Hitler wins the war. Perhaps the very first alternate world story might be created if Eve were to spurn the apple of knowledge in the Garden of Eden. In fact, with this, history might never happen. But in the case of science fiction, this could be a difficult plot. It seems that science fiction stories about time travel work much better if something is terribly wrong with the world and needs to be fixed. But there are many more examples. Perhaps Napoleon wins at Waterloo, or Columbus fails to find America, or the South wins the American Civil War. And again, the list is endless. But alternate worlds open up the possibility of worlds of choice, and the possibilities are endless. In these types of science fiction stories, there is a strong belief that action counts, and that the future is truly in our hands. Another similar type of story is a parallel universe story. In this type of story, whenever an event is changed in the past, a new parallel timeline is created. So the future timeline we knew would still exist and continue, but also a new parallel timeline would be created. But in each of these types of stories, the belief holds up that the world is up to us. One of my favorite, but less well-known space-time stories is Edwin Abbott's Flatland. Think about it. To the two-dimensional people living in this flatland, the three-dimensional creature, as it passed through their world, would appear to be remarkable, appearing out of nowhere, moving in ways they had never seen or could understand. To the Flatlanders, this creature would appear to be frightening, magic, perhaps even a god. It can make a person wonder, what would a fourth-dimensional being look like to us if it passed into and through our three-dimensional world? On the other hand, how would that four-dimensional being see our world? Let's go back to Flatland for a moment. As a three-dimensional being, it's easy for us to look at Flatland, like we do at a simple piece of paper, and see every part of their world at once. But how would a four-dimensional being see our world? What would our world look like to a being that could move through time as easily as we move through space? They would probably see all three dimensions from all perspectives at once. Actually, it was said that Albert Einstein often asked the same question in a slightly different way. He always wondered, what would it be like to view the world if you were riding on a beam of light? Remember, as we move faster and faster towards the speed of light, at the speed of light we would see everything compact into a single point, and we could see everything at once. But again, with most great vision and achievements, to do, one must first imagine. And just like science fiction, art has also inspired science in many ways. In fact, while Albert Einstein was asking this very question, a great artist with no knowledge of Einstein's work was already laying the groundwork for his new painting style called Cubism. This artist was none other than Pablo Picasso. In importance, Cubism has been compared to the revolutionary discovery of perspective in the Renaissance. In a Cubist painting, the solid reality of an object located in space and fixed in time crumbled away. The visual segments of the front, back, top, and bottom and sides of an object simply jump out and assault the viewer's eye simultaneously. Before this, for example, the different surfaces of a cube would require an observer to walk around through space to view them in sequence, and this takes time. But in a Cubist painting, the need to walk around an object in space and time is removed, and the collection of visual fragments would let the viewer experience the entire object from a single point in space and time. Perhaps the only other place in the universe from which an observer could actually see these ideas would be from astride a beam of light. Before Picasso's Cubism were artists like Monet and Cézanne, who began experimenting with time and art in a very different way. Monet, who painted the entrance to the Rhone Cathedral in 40 separate works, that in essence tried to capture a cathedral that existed in time as well as in three-dimensional space. And Cézanne, who in a single painting would move in time around the painting, creating works with perspectives that were distorted. After Cubism and Einstein's discovery, many new art techniques would follow the new physics. Salvador Dali perhaps reflected the new physics of curved space and time better than any other artist. M.C. Escher's works use a clever manipulation of perspective. What appears to be correct to the eye on closer examination is wrong. Escher takes what we think is our clear understanding of the shape and nature of three-dimensional space and makes us consider other kinds of geometry. Another great artist, Constantin Brancusi, captured time in his sculptures in the most remarkable way. One of the most magnificent collections of his works is located in Romania. These works show the great river of time, turning the wheels of life in his table of silence, which lead to a walkway through time, to the gate of the kiss, a symbol of life, marriage, and new beginnings, and then on to the never-ending column, a remarkable work capturing the characteristics of time that both art lovers as well as physicists could appreciate. To do, one must first imagine. There are many more examples where art and science fiction intuited science fact, but the pure imagination and genius of one man led the scientific revolution of our views of space and time. In 1905, Einstein introduced his special theory of relativity that suggested that very fast speed can dilate time. What this would mean, if true, is that time was not unchangeable and that time travel to the future would be possible. But Einstein's views and theories were not accepted or taken very seriously by many people at this time. Then in 1916, Einstein introduced his general theory of relativity. This suggested that heavy gravity could curve or bend space-time and that it could also dilate time. Again, his theory was not accepted. However, there was one interesting point about Einstein's general relativity that caught the attention of scientists around the world. For hundreds of years, the Newtonian model of the universe served scientists well. They were even successfully used to predict the orbits and locations of planets in the heavens. But there was known to be a flaw in Newton's model. It seemed it could predict the locations and orbits of all the planets except Mercury, the planet closest to the Sun. Is it possible that the gravity of our massive Sun was distorting space and time around this planet? In fact, it was, and Einstein's general theory of relativity explained it almost perfectly. General relativity explains the Mercury orbit. However, Einstein's theories of relativity were still not accepted. Most scientists thought that this was just a mathematical trick or coincidence. They didn't believe that space and time could possibly be curved. But to a few, Einstein's theories became more than just a curiosity. And to prove it, all they needed to do was to demonstrate that a massive body with very heavy gravity could curve space and time. Well, not the easiest problem to solve in the early 1900s. That was until a suggestion was made that could prove once and for all whether Einstein's theories were true or false. The idea was to look at the light of a distant star that was passing near the edge of the Sun, and then compare its measured location here to its measured location when the Sun is not between it and the Earth. A perfect idea. If the gravity of the Sun could truly bend space around it, then the measured locations would be different. The only problem, to do this, we would have to be able to look up at the Sun and see starlight in the middle of the day. Not an easy task considering how bright the Sun is, and that we can't see starlight in the daylight, except during a total solar eclipse. An incredible excitement grew, and expeditions from all around the world were sent out to view the eclipses of 1919 and 1921. As results came in from around the world, it was clear Einstein's theories were correct. In fact, his predictions were so accurate that all the doubt around his theories fell, and Einstein's theories were finally accepted. And the world opens its eyes to a new reality and a new science. Time is no longer a constant. Newton's universe crumbles and a race to explore the new nature of time and space begins, and it's followed by a flurry of events and advancements. In 1937, Kurt Gödel proposes that the universe is a time machine. In his model of the universe, it was theoretically possible in these worlds to travel through time. In 1949, Kurt Gödel again proposes that pathways through time are possible using something called closed time-like curves, an idea that shows how heavy gravity can curve space and time in a way that might allow time to actually loop back on itself into the past. His work was the first to suggest that reverse time travel could be possible without violating the laws of mathematics and physics. General relativity predicts that if a massive star experiences a total gravitational collapse, that a singularity in space and time would be formed. This object could have a gravitational field so large that even light could not escape it. Appropriately, in 1967, the great American physicist John Wheeler introduced the term black hole to describe the spectacular singularity in space and time, a term that is well known today. It is speculated that the singularity at the center of a black hole might be a place perhaps where time itself ceases to exist. Later in 1974, Frank Tipler shocked the scientific community when he published a paper that appeared to be plans for building a time machine. Using a massive rotating cylinder in space, Tipler showed how not only forward but reverse time travel were both possible without violating the laws of mathematics and physics. By flying through a carefully plotted spiral course around the cylinder, a traveler could find himself moving both forward and backwards into time. This rotating cylinder model continues to be one of the best examples that shows how time travel is clearly possible. In 1986, I was fortunate to be able to make my own contribution in space-time study and research with the introduction of what is called today time warp field theory. Time warp field theory is an approach that allows the creation of a field within which time rates can be adjusted without requiring the massive amounts of energy that was previously thought to be needed. Another scientist today making many contributions to space-time study is Kip Thorne. Kip Thorne has suggested many methods of using wormholes for time travel. In one example, using a rotating black hole, he showed that it might mathematically possess in its interior hyperspace tunnels to other places, either in our universe or perhaps to other universes. A wormhole, in effect, could connect two places separated by a very large distance to each other, through a distance that was very small inside of the wormhole. Thorne's approach would require an advanced technology that could master and use the energy within the black hole to make the trip. But in a different way, Thorne shows here once again that even though time travel may be very, very difficult, it is not impossible. As his work continues, Dr. Thorne has even suggested using exotic matter to capture and control wormholes that might occur naturally at the quantum level in what is called the quantum foam. The advances following the acceptance of Einstein's theories of relativity have been many, and since the 1920s, his theories continue to be proven over and over again in many different ways. The most important realization out of all of this is that forward and backward time travel does not violate the laws of math and physics, and as we know, when mankind knows something is possible, we usually find a way to make it happen. One of the most interesting moments in the recent history of space-time development was that of Stephen Hawking when he published his famous chronology protection conjecture. In this work, he denies the possibility of time travel because we have not been invaded by hordes of tourists from the future. Using this almost as experimental evidence, he really stopped and made the scientific community pause and think deeper about the possibilities of time travel. So if time travel will be possible, where are all the time travelers from the future? From here, many theories arise. Perhaps we've not seen them because when a time traveler comes back in time, a parallel universe is born, where he exists, but we don't. Or perhaps time travelers cannot go back any earlier than when the first time machine is built. Or perhaps many people might say there is evidence that we have seen time travelers from the future. Millions of people around the world, people including doctors, scientists, presidents and kings, and many others, have claimed to have had sightings or encounters with unidentified flying objects and aliens. Is it possible that these sightings are of time travelers from our own distant future? Our legends and folklore are filled with stories about UFO sightings and contacts with aliens from other worlds. Is it possible that these stories are not about visitors from a distant world, but instead that they are time travelers from our own distant future? In these alien sightings, the creatures have many human characteristics. Is it possible that they are time travelers from our own planet, visiting us from thousands of years in the future? History is filled with many stories and legends about visitors from time, and also about our own experiments in time. One of the most well-known stories about secret experiments in time is known as the Philadelphia experiment. In 1943, it is said that the U.S. Navy was conducting invisibility experiments aboard a ship called the USS Eldridge, using Einstein's unified field theory. The objective of this experiment was to make the ship undetectable to radar, and while that was achieved, there was a totally unexpected and drastic side effect. It is said that the ship became invisible to the naked eye and was removed from the time and space as we know it. Although this was a remarkable breakthrough in terms of technology, it was a catastrophe to the people involved. Stories say that not only the ship, but the sailors had been transported out of this dimension and returned in a state of complete mental disorientation and horror. Some were even planted into the bulkheads of the ship itself. Those who survived were discharged as mentally unfit or otherwise discredited, and the entire affair was covered up. But it is also said that that research continued to find out why that had happened. In about 1970, the program was said to be fine-tuned and applied on a much larger scale. It is said that the massive underground complex near the Montauk Air Force Base on Long Island was selected as the site that would continue where the Philadelphia experiment left off. As the experimentation continued in these underground facilities, control of the space-time continuum was achieved and exercised on a regular basis. It is even suggested that these secret experiments may still be continuing there today. The story of Montauk is a fascinating one, and careful study will show that there is definitely activity in the area that is difficult to explain. Perhaps one day we'll find the truth about what is happening here. There are many great stories about time travel and time travelers, and in many there may be basis for truth. But there is one truth today that is indisputable, that time travel may be difficult, but again, it certainly does not violate the laws of mathematics and physics. And the developments of new scientific theories and methods has continued with many exciting new developments yet to come. In 1991, Richard Gott suggested another way to create pathways backwards in time. His idea was based on a theoretical object called a cosmic string that might be left over from the creation of the universe. If two cosmic strings were to pass close to each other, or one was to pass near a black hole, a pattern of closed time-like curves could be created. By flying a carefully calculated course around the string, it would be possible to emerge anywhere, anytime. The concept and basis of many worlds theory in science was pioneered by Hugh Everett III. The many worlds theory states that if a time traveler returns to the past and makes a change, then reality will split into two timelines. One where the change never happened, but also an alternate timeline where the change did happen. Perhaps in every second, our reality continues to split into an unlimited number of parallel timelines. It's a fascinating concept and one that still attracts serious researchers today. Later, in another move that shocks the scientific community, Stephen Hawking announces that he believes that time travel is now possible. And like many scientists, he even encourages more funding and research to advance our understanding of the physics of time. When we speak about time and time travel, we must also speak of the fascinating new theories of hyperspace and also superstring theory. One of the world's leading scientists in this area is Michio Kaku. At the end of Dr. Kaku's quest for the theory of everything, we may find answers that will unlock the deepest secrets of creation and answer some of the most intriguing questions of all time, such as what happened before the Big Bang, whether the past can be altered, and if gateways to other universes really exist. His work and vision is truly remarkable and is leading the way in helping us all to understand the true meanings of space and time. In 1995, I made my own serious commitment to the study and development of time control technology. In an aggressive move, I founded a company called the Time Travel Research Center. The Time Travel Research Center is a privately owned research laboratory based on Long Island, New York, in the United States of America. The company is exclusively dedicated to the advancement of the science, technology, and research that will deliver practical time control capabilities and applications. We are a leader in the development of capabilities to pursue this goal and are the only company of its kind dedicated exclusively to pursuing the development of time control technology. At the core of our research is what is known as our time warp field theory and technology. We also support private research and development and also pioneered and managed the development of the TriStar system. Our TriStar simulation system represents one of the most advanced space-time virtual laboratories in the world today, designed and optimized specifically for research in this field of study. The Center also founded and manages the Time Travel Research Association. The association networks information and interest on the study of time and time travel from all around the world, providing an exciting forum to study and learn. With more than 15,000 members from more than 90 countries, the association is the largest time travel interest group in the world. I entered the world of space-time physics when I was recruited at a young age by the United States Air Force. I spent almost 5 years as an Air Force officer, flight test engineer, and scientist conducting advanced space-time research at the prestigious Air Force Flight Test Center in the Mojave Desert. The focus of my work was in the research, development, test, and evaluation of space-time models and systems. It was here at the Air Force Flight Test Center that I began building a detailed understanding and a true passion for space-time physics. After leaving the Air Force, I began to develop what I labeled time warp field theory to describe new relationships between time and energy. Since then, I have spent all of my time working to fund my research, advance my theories, build our TriStar virtual laboratory, and plan the launch of the Time Travel Research Center. Our technology involves the creation of a self-contained spherical time warp field, about 30 to 40 centimeters in diameter. Within the boundaries of a time warp field, it is possible to actually accelerate or decelerate to a certain degree the rate at which time passes relative to the rate of time outside of the field. The applications for this technology are many. We are currently researching several applications in the medical field. One would be transplant organ preservation. The time warp field will be used to preserve organs or tissues awaiting transplant. In this case, the organ would be stored in a special container within the time warp field. Here it would be exposed to a significant retardation in the rate of time passage that would keep the organ healthy and fresh for a longer period of time. This will greatly increase the success rate of transplant operations and will also provide a solution for organs to be stored and made available for longer periods of time, so they can be available when they are really needed. Another area of great interest and application of this technology is for scientific test acceleration or retardation, not only in the medical field but in many others. In many disciplines, the speed at which research can be accomplished or results can be produced is gated by the length of time required by certain natural processes or chemical reactions. Utilizing the time warp field technology, we will be able to actually accelerate this testing and research, and hopefully without compromising the quality of the results. This will have tremendous advantages in many industries and research around the world. The number of new avenues in research and development this could open up are significant. There are still many technology challenges we need to overcome. Perhaps in some areas we still have more questions than we have answers. But we don't exclude the possibility, and we even anticipate that after much more development, that we'll be able to create stasis fields and then eventually certain types of disease regression capabilities in the future. But given the dangers, it is much better that we walk before we run here. We see tremendous promise for the application of this technology for medical and healthcare use. The impact this technology could have on accelerating research and finding cures for diseases like heart disease, cancer, diabetes, and AIDS is profound. We also believe that our TWF technology will eventually permit certain types of actual disease regression as our development continues and we find safer ways to use it on a living person. But in the short term, the benefits in accelerating and opening up new avenues of research will have such a large positive impact that we feel it may entirely change the way the world looks at and performs research, and may help us move more quickly to new cures or treatments for these diseases. Our virtual laboratory is key to analyzing and learning more about time warp field technology and its application. Our simulation programs may represent the most advanced space-time virtual laboratory in the world. The TriStar System simulation programs were designed with one goal in mind: to advance our efforts to achieve time control technology. It is a very unique scientific research platform. The system is probably most unique in that it is very flexible and quickly adaptable to the various types of TWF analysis and testing we need to do. By bridging the walls between physics, mathematics, and computation, and injecting our space-time model, the TriStar system now delivers a powerful research and development environment for us. The system is used extensively before and after our live experiments to compare actual results versus computer predictions. More and more, though, the greatest value has been in exploring and documenting the nature and possible applications of time warp field boundaries. The nature of the field boundaries is quite complex, but if our research continues to resolve itself as we've planned, and we predict it will, we will all be seeing some fascinating changes in the opening of an entire new industry based on this technology. At the Time Travel Research Center, we are dedicated to developing time control technologies and applications that will benefit the world. Every day, physicists are continuing to prove rationally that our rational ideas about the world in which we live are profoundly deficient. The final acceptance of this new knowledge will transform our world and reality in a manner that is difficult to comprehend. An example of how these new discoveries will shatter our view of the world and reality can be seen in the new views we see in the simple and most basic concepts of reality, like the concept of time. As science continues to make us doubt our own perception of reality, it forces us to ask an important question: what will the impact be on our views of spirituality and religion? Physicists have always been separated from the worlds of philosophy and religion by the strict walls of analytical science, but something very exciting may be happening. Is it possible that today's physicists are simply rediscovering the ancient wisdom that shows the sense of wonder and oneness that connects us with the universe and God? The new discoveries in what is being called the new physics is crossing into and driving support for many long-standing views that have been held sacred by some religions for thousands of years. In the last 10 years, high-energy scattering experiments have continued to show us the dynamic and ever-changing nature of the subatomic particle world in the most striking way. Using particle accelerators and supercolliders, which are enormous circular machines with circumferences of several miles, protons are accelerated to velocities near the speed of light and are then made to collide with either protons or neutrons. Matter has appeared in these experiments to be completely mutable. All particles can be transmuted into other particles, matter can be created from energy, and it can vanish into energy. One scientist ahead of his time in this area is Mihai Dragonescu of Bucharest. In Dr. Dragonescu's new view of the world, classical concepts such as elementary particles, space, time, material substance, or isolated objects have lost their meaning. Instead, he sees a universe in reality whose fabric is woven only of information and energy. Without a doubt, these new scientific tools, theories, and research are closing a circle and leading to the same conclusions of many ancient beliefs. This conclusion is that the world and everything and everyone in it are all part of the same inseparable dynamic web of energy. Since we are a part of this web of energy, is it also possible then that the human mind could master time? Or is it possible that the human mind itself is a time machine? In physics, the special theory of relativity states that by accelerating and moving it close to the speed of light, we can actually dilate time and make time pass more slowly for a person who is traveling so fast. In this way, one could travel forward in time. Neurophysiology states that the process of the brain, including thinking, are achieved through the process of depolarization and repolarization of the membranes of the neurons that build the nervous system. The end result is the creation of electrical currents and energy. We know from Einstein's famous equation E=mc² that mass and energy are interchangeable, but it is certain that energy will be far superior to mass if we are trying to accelerate one to near the speed of light. Any mass, no matter how small, would require infinite energy to reach the speed of light. According to modern physics, this is not possible, and light speed is a real limitation for any object. However, energy may be a different story. Pure energy can travel very easily at the speed of light. By considering all the above, can we conclude that thinking, which is an energy-mediated process, should allow for the processes that govern time viewing, time travel, and phenomena such as precognition? These possibilities are now being explored around the world. The groundbreaking work of people like Dr. Bruce Goldberg, Rick and Louisa Clarici, and others continue to deliver new techniques and promise that will help people around the world tap into this power of the human mind. By continuing to explore the energy-mediated processes of the human mind, we may begin to better understand that it may be just as easy for our mind to interact and possibly control time itself. The effect of these new discoveries on our culture will be staggering in its power to lead the people of the world to enlightenment. The majority of our world population still embraces the material and scientific as the only real truth of reality. It's ironic that for the first time, it may be these very scientific beliefs that will cause many to look beyond the walls of analytical science and step into a deeply personal, thoughtful, and inspiring journey that will help them find their true place in the universe and the universe within themselves. The impact of science, religion, and philosophy, now aligned so closely for the first time, cannot be underestimated. This could open a floodgate, ushering the masses of the world's population into the new age, and lead to a new enrichment of the human experience for more people across the globe than ever before experienced in the documented history of civilization. It is very impressive that this new view of the universe, the same views held by metaphysicists and Eastern mystics for thousands of years, is now being rediscovered in the strangest of places, in the scientific laboratories all around the world. So what is time? The answer is still close, but very elusive. It hides right in front of us, in our philosophy and our religion, in our science fiction and science fact, in our art and folklore, and in our mathematics and physics, even in our own human spirit and mind. When did time begin? Was it when the universe began with a bang or was summoned into existence by some great force? Perhaps neither, or both. Will time have an end? Maybe we should travel to the future and find out. Perhaps when speaking of time, only one thing is certain. Our journeys into time are just beginning. Thank you for joining us in exploring the possibilities of time travel. And who knows, perhaps we'll meet again. Yesterday? Well, one thing I do know is that time is a very curious thing. Ask anyone on the street if they know what time is. They are sure to answer yes. But then, ask them to explain it to you, and they will almost certainly be at a loss for words. Think about it. Something that dominates our language, our everyday thoughts and life, but yet we can't explain it, nor do we understand it. Perhaps in some ways, we don't want to understand time. People do often talk about time in a very negative way, perhaps because in some ways it is linked to our own mortality. A very popular quote about time from the science fiction movie Star Trek Generations is, "Time is the fire in which we burn." Another is the famous quote from Hector Berlioz, a great 19th century composer who said, "Time is a great teacher, but unfortunately it kills all its pupils." But this still doesn't explain what time is. We seem to have a belief that time exists independent of us. But is it perhaps only something that is measured only by our minds and bodies' perceptions? We all seem to have biological clocks inside of us that work on a set schedule, and our minds perceive the passing of time in many different ways, even for people experiencing the exact, very accurate calendars to keep track of time. The megalithic stones of Stonehenge in Great Britain are an example of such a calendar. And the Mayans of Central America had a calendar based on the sidereal year that was just as accurate as the calendars of today. These early measurements of time were based on the spinning motion of the Earth and its rotation around the Sun. It is now known today that these motions are not constant but do vary in time. As history progressed, methods of measuring time's passage became more focused on very regular oscillations of such things as springs and pendulums. Today, official time is measured by atomic oscillations of cesium to an accuracy of parts per billion. We have found many ways to measure time, but still, when we ask the simple question, "What is time?" we cannot answer. This is not a new fascination with the nature of time. As early as the 4th century, St. Augustine said it very well with his famous question and answer, "What then is time? If no one asks me, I know. If I wish to explain it to one that asketh, I know not." This is indeed a very powerful and sharp insight into the psychology of time, and a very, very old and still unanswered question. Imagine traveling in time, some process that would let you go backward in time to witness the events that change history, or into the future to see if mankind survives, and then to return to the present with the knowledge of what will happen tomorrow. The process is intriguing, even mind-boggling, but the science is more real than imagined. The quest for the technology permitting time control is now underway. Private and government investment in this area of research is on the rise and fueling a race leading to discoveries that will change our world and our very sense of reality in ways difficult to even begin to comprehend. This science is real. The advances underway are truly exciting and the possibilities are endless. Join us now as we explore the possibilities of time travel and begin our exciting journeys into time. Hello, I am Dr. David Anderson, and I thank you for joining us as we prepare to take some exciting first steps as we journey into time. Perhaps the best place to begin is at the beginning, with a definition of time. What is time? What is it that clocks are measuring? They seem to measure some unseen medium that continues on with a constant and never-stopping force. In fact, time is often thought of as a river that flows in one direction and slows for no one, always sweeping everything and everyone along with it. We certainly experience the passing of time. We are born and live our lives feeling as though we are constantly being pushed and pulled by this unseen phenomenon. So then, what is time? Same events. Time also seems to vary with culture. For instance, in the language of the Navajo, there is no past, present, and future tense like those of many languages. Events are talked about with regard to their quality of happening rather than their temporal quality. Is it possible, then, that time may not really exist, but is just an illusion of our mind, created by our own biological and cultural evolution? Well, whatever time is, one thing is certain: man has always had a passion for finding better ways to measure. When it first became important for people to measure time, they didn't have or need wristwatches or clocks. All they needed to know was when the winter was coming, or when they could plant or harvest their crops. For this, the ancient peoples of the earth used the regular cycles of nature. For instance, it was known to them that the sun rises and sets in a regular and predictable way. It was also known that the moon, stars, and planets have consistent and predictable motion through the heavens. And they could keep track of the passing of a day with sundials and other similar instruments. With this knowledge, they could predict the coming of different seasons. There were many ancient peoples that devised